Ollie, thank you so much. Great to be with you all today. Appreciate the introduction. Thank you, Carosoft, for allowing us the opportunity to present today. Let me just share my slides here. Hopefully you all can see them now.
Yeah, all good, Evgeny.
Wonderful. So again, thanks for spending an hour of your time with us today to learn about the fascinating world of FIPS 140-3. So we'll try to make this as as interesting as possible for you all today. It is finally here indeed, and we'll be talking about the implications for federal agencies, vendors, system integrators. So hopefully today will be everything you ever wanted to learn about FIPS 140-3, and hopefully you'll find the session useful. So we'll start with some overview on what is FIPS 140. We're not necessarily assuming any prerequisite knowledge coming in, although I would imagine that you've probably heard about FIPS if you're in this webinar here. We'll talk a little bit about sort of FIPS 140-3 versus -2. So what has changed? Why the new version of the standard? So we'll talk about that. We'll talk about what the future holds for FIPS 140-3 and migrating to FIPS 140-3. And we'll certainly cover the implication again for the government agencies, for the technology vendors that sell solutions to the government, for the system integrators. What does it really mean to get to FIPS 140-3? It can certainly be a pretty big, significant lift. Our goal here at SafeLogic is to simplify and accelerate this process. So we'll talk about that today. So first of all, just to kind of provide you with a bit of a history. So obviously, cryptography is pretty fundamental to cybersecurity in general, right? So we kind of oftentimes think of cryptography as plumbing, right? Kind of plumbing in the building. You don't necessarily think much about plumbing until something breaks, something goes wrong, there's a water leak, but it's a pretty fundamental. So really, the way we kind of think about it is it's really foundational to digital, privacy and trust and security. A lot of it is built on cryptography working. So it's not a surprise that it is a pretty highly regulated areas, at least as far as the government is concerned. So the government obviously works closely with NIST, the National Institute of Standards, and over 20 years ago now, National Institute of Standards came up with a standard called Federal Information Processing Standard, which is FIPS. So to go back to my plumbing analogy, when you have your plumbing, the plumbing has to be up to code, right? So really you can think about FIPS 140 as code for how you should implement cryptography. Because what the government really wants to make sure is that when cryptography is built into the products and services that it's using, and again, it's pretty much ubiquitous these days, that cryptography is not just somebody woke up one day, went to the basement, coded something up, and they called it cryptography. They really want to make sure that it's been properly vetted and validated. And so FIPS 140 really has those requirements for implementing cryptographic modules. And it's a pretty rigorous process that you have to go to. First, you go through testing by laboratories. That there's about a dozen laboratories that have been certified by NIST to do this across the US and Canada. And then you go through the NIST process, again, very extensive review to make sure that the cryptography meets the requirements from NIST. And so it has been adopted by a variety of other regulatory regimens. So whether it's FedRAM, Common Criteria, CMMC 2.0, FISMA, and so forth, ultimately, when they talk about cryptographic controls, they want to make sure that wherever you have government data in transit or in storage, that it's being properly, validated, by NIST, and so it actually meets those standards. So just a little bit of I see a polling question, so I'll give folks just a second to answer that. Okay. So again, the history of FIPS goes way back to 94, where you had, version, 140-1 kind of established those security requirements for modules. Um, it was a set of basic requirements. The current iteration, or I should say the current is -3. The one right before, the one that's still kind of the most ubiquitous right now, is FIPS 140-2. So it's been around since 2001. So it's been around for over 20 years and really has been a very successful standard and very, very widely adapted. And I don't want to give you a sense that it has been static for the last 20 years. Far from it. There's constantly changes in the standard that NIST has to introduce to, what's actually allowed and what are the benchmarks and standards for implementations. And the reason that's important is because our adversaries are not standing still, right? Like, so the bad guys are continuing to improve their cryptanalytic techniques. Obviously, computers get more and more powerful. And of course, we'll talk a little bit later, but now we're kind of like standing on the precipice of having quantum, computers that are going to create a lot of problems for us in the cryptography world. So there's constantly changes that have been happening to the FIPS 140-2 standards, the latest, iteration is now FIPS 140-3. Which really kind of got finalized about 5 years ago, but it's just now kind of really becoming kind of widely, adapted, in the industry. What were some of the drivers for getting to FIPS 140-3? Well, one of the drivers was the desire to get a closer alignment with international standards. So FIPS 140-2 is very much sort of US and Canada, right? But now you have FIPS that really gets adapted by many other governments out there as well, and then outside the US. So there was a desire to harmonize with some of the ISO and IEC standards. So that was part of it. But the other part of it is just to continue raising the bar and adding additional security requirements and testing standards, which we'll talk about in a second when we talk about some of the differences. So again, the main points here is that FIPS has been, dynamic. There's been changes that have been happening over the past 20 plus years, but now we have this quantum leap, if you will, into FIPS 140-3. And speaking of quantum leaps, right? So there are, additional things that are happening in the world of cryptography right now. So you might have heard about this, but just in August of this year, NIST actually standardized 3 post-quantum cryptography algorithms. So it's been one KEM is key encapsulation mechanism, and 2 digital signature algorithms. So just real quick, why do we need, those new algorithms? Quantum computers are getting better and better. In fact, if you look at Gartner, they actually identify, migration to post-quantum cryptography as one of the top 10 technology trends of 2025 that they expect. And they actually expect that perhaps as soon as the end of this decade, we'll have what's called cryptoanalytically relevant quantum computers, CRQCs. That means that they are going to be capable of breaking our asymmetric public key cryptography. So think RSA, elliptic curves. So about 8 years ago, NIST started this competition where they had the best and the brightest submit their candidate algorithms that we believe are going to be not breakable by quantum computers. And that was a long, extensive process. And just this summer, again, NIST standardized the first 3 of these algorithms. So now for folks who have been waiting for, standards, no excuse anymore. The standards are here. As a matter of fact, the same day that NIST had announced those new algorithms, they also said that there's now support for those as part of the FIPS 140-3 process. So cryptographic vendors can start doing their implementations of PQC algorithms. They can start testing, and they can start building it into their future FIPS 140-3 modules. So we'll tell you in a little bit what we're doing about that here at SafeLogic. And so, things will continue to change. So for instance, in terms of FIPS 140-2 to FIPS 140-3 migration, the latest date that any FIPS 140-2 module can stay active with NIST active meaning that it's currently meeting all the requirements, is September of 2026. That is not to say that all of them will stay active until that date. The modules will start sunsetting, the -2 modules, based on their certificate, expiration dates. But the latest that any module can stay is September 26. So that really does create that need for organizations to have a good plan, how they're going to get before that date from -2 to -3. And then it's important to make sure that there's a good plan to deal with future cryptographic transitions, because again, like we mentioned, there's going to be post-quantum cryptography that right now the agencies are being asked by 2035 to migrate at least their high priority systems to not be vulnerable to quantum computers and adopt PQC. That sounds like a little while, but it's really not because of the scope of work. So that's going to be a transition. And then there are other transitions are coming. For instance, you mentioned, you'll see that we mentioned entropy source validation requirements on this slide. This is something else where the NIST is getting more and more stringent about sources of entropy. So, if you kind of think about cryptographic system, you have three pieces, right? You have the algorithms themselves that have to be secure. That's broadly speaking kind of what NIST does, help us run competitions when there's threats to that, like quantum computers developing new algorithms, right? So this is algorithms have to be secure, okay? Then the implementations of those algorithms have to be secure, which is essentially what FIPS 140 standard does. So like vendors like SafeLogic, they go implement those algorithms, take them through the process with NIST to get a stamp of approval so that people can feel confident that what they're adopting meets that cryptographic code, right? But then the third piece is really the cryptographic, the key material has to be random enough. So if you have a strong algorithm, strong implementation, but you have a weak key because the key was generated without having proper entropy. Entropy just basically means, the degree of randomness. That can really break the whole crypto system. So NIST is really getting more stringent around what the requirements are there around how you're getting your entropy and whether have hardware or software entropy source, has it been validated and vetted by NIST to know if it's any good. Because if you're using that entropy to generate the key material, obviously, if it's not a good source of entropy, that can really break the whole crypto system. So I pointed out is because FIPS 140-3 is not the only transition you have to worry about. You'll have to worry about PQC. You have to worry about, entropy. And again, on average, I would say there's every 6 months or so, 6 to 12 months, NIST has traditionally had some what's known as hard transitions with FIPS because of, again, the bad guys are not standing still. Cryptanalytic techniques are continuing to improve, so we need to continue evolving. So this is really not a one-time and done challenge. It is really what we call a continuous journey, really, to make sure that your cryptography, meets the, continues to meet the requirements. So just real quick, there are actually different levels of FIPS, and those levels don't have anything to do with FIPS 140-2 or -3. Sometimes people get confused about that. Within FIPS 140-2 and within FIPS 140-3, there are different security levels. Level 1 is sort of what most organizations go for, is really cryptographic modules that have been basically software only, right? So everything is on software validation, is on the software implementation of the cryptographic modules. As you get to levels 2, 3, and 4, you get progressively more tied to the hardware. And then you also see, as you can see from this graph, significant reduction in the certificates that get issued. It's harder to get, fewer people go after that. So level 2 adds physical security requirements like role-based authentication and authorization for module administrators. Level 3 will add some additional identity-based authentication mechanisms and additional physical security requirements. And level 4 is even more, where you really need some extensive proof of tampering if you're operating in some really not trustworthy environments from a physical perspective. For the purposes of this presentation, what we're going to be focusing the most here is level 1. So just kind of to emphasize, we're kind of focusing on the software level, so whether it's software or it's firmware, but basically that's kind of what the focus of this discussion is. But we did want you to understand there are different levels to FIPS, and certainly if you require level 2, 3, or 4, you will already know about it because you would just know about it at this point. So traditional approach to getting FIPS 140 validation is really not for the faint of heart. And it's really not just about getting it, but it's also about maintaining it over time. So just not to belabor this point too much, but what a typical historical sort of approach, traditional approach looks like is, most organizations don't have a lot of in-house FIPS expertise, right? So they typically would have to hire a consultant to work with them to design a cryptographic module, to document it, to make sure that it gets properly tested and all of that. That will take time. Then you would have to go work with one of about a dozen laboratories, again, across the US and Canada that have been certified by NIST to do FIPS 140 testing. And you would be working with the lab for, 4 or 6 months or more to really, get your module rigorously tested by the lab. There's algorithm testing, there's operational testing, there's now with -3, there's, code reviews. They will also want to review your, self-development process. There's a lot of things that are involved before you sort of, get the lab to sort of move you forward in the process, which would be submission to NIST, right? And this is where you go to the, NIST, what's known as Cryptographic Module Validation Program. It's a very rigorous process where NIST will also review all the documentation, review your module, review, everything, do their own testing. And then, no guarantees, but if you meet the requirements, eventually you will get your FIPS 140 certificate. Right now, if you were to start this journey, given how long things take with the labs, and especially with NIST, I mean, there's a queue. You have to go through the queue because a lot of people are trying to get this. You're probably looking at 2+ year process, A to Z, to go and get your FIPS 140-3 validation at this point, because you can no longer apply for -2, so it would be -3. And the testing will have to be pretty extensive. It would have to be done on all the different operating environments where you want to have your module certified. So that means, operating environment is really a combination of operating system and CPU architecture. So you will need to get your module tested in all those places. So again, it's a pretty rigorous process that will, will not be a one and done, because even after the 2.5 years after you get the certification, because the requirements will keep changing in the FIPS standard, you will have to keep doing work to keep your module active with NIST. And so this is actually an important point to understand. So if you go to NIST website today, so if you Google NIST CMVP, Cryptographic Module Validation Program, you can actually do a search and you can see what modules are active status, meaning that they currently meet the requirements. But you'll find a lot more modules that will say historical status. In historical status, what that means is that, in layman's terms, it means that once upon a time, this module used to meet FIPS requirements. But for some reason, it does not anymore. Usually it's because there was some hard transition with NIST, maybe key sizes changed or some algorithms became disallowed or some padding scheme changed, and the module went historical. So at some point, again, all the FIPS 140-2 modules will go historical, again, no later than September of 2026. So historical is not a great place to be. I mean, it doesn't mean that your module is like no longer valid or revoked or anything like that. But what it means is, for the purposes of government procurement, in most cases, for new opportunities, you're going to be blocked out because the government really wants to see that your cryptography that you're using is actively currently meeting NIST standards, not used to meet them, but not anymore, right? So for existing installations, it will be kind of agency by agency decisions, how long they decide to allow you to use a module that's historical. They may allow it for a certain period of time, but not indefinitely. So, so ideally, what you want to do is to keep your module active. And if you were to do this all yourselves and kind of, again, go through this 2.5 year process, that would become a nonstop, effort, for organization. And the reason it's so challenging to keep, one of the reasons it's challenging to keep module active is because once you get it validated, you have this thing called the security boundary. Anything within the security boundary, any code change within it, whether it's a CVE or a bug fix or whatever, would invalidate that module, would necessitate for you to go through the process to essentially get that code relooked at, right? So So it's challenging, especially if you are new to this and you're designing a cryptographic boundary. A poorly designed cryptographic boundary can kind of doom your validation, from the very beginning. This is why this is really something that's, to be perfectly honest, best left to the professionals and not having to kind of like do this yourself. This is not a great DIY project, but this is kind of what you want to avoid. You want to avoid, being historical, because it can really come at a bad time for you and can really cause procurement challenges. So also just important to understand some terminology, right? Sometimes people kind of throw words like compliant, certified, validated. So I just kind of wanted to tell you a little bit kind of how we see those terms. Sometimes people use compliant as in, we implemented something and we believe we meet FIPS 140 requirements. Well, that's not compliant. That's really nothing, right? I mean, somebody just believing they meet requirements doesn't really hold water. The only entity that matters believing that is really NIST, right? So unless your module has gone through the process, you're not really compliant. So, how we define compliant is essentially if you're using a FIPS 140 validated module that somebody else validated, and you're using their module, you're using their certification, you don't have any certification in your name. So we kind of define that as you are FIPS 140 compliant because you can point to somebody else's module and somebody else's certificate, but you are not certified / validated yourself. So to be / certified validated yourself, you really need to have on that CMVP website that we showed, you really need to have certification in your name that lists your operating environments, your products, and so forth. And that really tends to be the gold standard. So if you go to federal procurement, to be able to point to say, well, here is our FIPS 140 module. You can see here from the NIST records, it's active. It has our product names. It has our operating environments. So it really, demonstrates that you actually are validated / certified against that gold bar. And it's really vastly more, it's superior to just being compliant, because in the case of being compliant, again, you're using somebody else's module, but somebody else might not keep that module active, so it may go historical, so that will create problems for you, so you kind of don't have that control. It also may not have your operating environments, probably doesn't have the exact set that you need, so it doesn't sort of make any claims around sort of operating environments where you have your products running. So typically you want to be certified / validated, not just compliant. And in some cases, without having your own FIPS certification, if you are a technology vendor, you may not be able to get that the deal that you're trying to get, because you don't have your own validation, especially if your competition does. It can be a competitive disadvantage. And of course, if you do have your own certification and validation, right, that can conversely be a competitive advantage. So we typically always recommend trying to get certification in your name. So, yeah, there's a polling question. So let's take a second for that. I promise just to give you a little bit of an overview of like what are some of the differences with FIPS 140-3 versus -2. So again, alignment with the international standards. There are some enhanced physical security requirements, especially as you go to the higher levels of FIPS, like level 2, level 3, level 4. By the way, I didn't mention this before, but it's important to understand that even if you go to level 2, level 3, level 4 for FIPS, the requirements for the cryptographic software are no different than they are on level 1, right? So in other words, a lot of the time, even if you need to go to level 2, level 3, level 4, it might be helpful for you to get a validation first at that level 1 for the software, because how you implement cryptography at the software layer, the requirements for FIPS don't change. It's just it begins to introduce some additional requirements for the physical security and so forth. So the software implementation requirements, the level 1, they're still there and they're still the same. There's some improved key management practices. There's also increased focus on software security. So this is kind of important to understand. So with FIPS 140-3, NIST is saying it's not just enough for you, Mr. Vendor, to show us that your module meets the dash 3 requirements. You also need to show us what was your security, what was your development process? What was your software development process that you used to create the module? And did it have all the requisite quality and security checks and gates in it? So in other words, it's kind of pushing vendors who do this for a living to really up their game when it comes to having, a secure self-development environment. Because, I spent, my background is actually software security. I spent 20 years in software security. You don't get secure products by accident. It's really a result of security aware SDLC. And this is essentially what NIST is saying here. And there's also other, government regiments now around secure software development attestations and things like that, which many of you will know about, really raising the bar on what is the process that you're using to create the software. And of course, including cryptographic software, right? So that's now part of the FIPS 140-3 standards as well. There's also additional updated testing and validation processes for the labs themselves. So the labs have more rigorous set of processes and checklists they have to go through with FIPS 140-3, which again, makes this, makes going through this process, especially if you're trying to do this on your own, more and more complicated because the bar has been raised, right? So yeah, so really the short term, the biggest challenge the industry faces is transition from FIPS 140-2 to FIPS 140-3. Again, the latest -2 is going to be active is September of 2026. So I think I mentioned this a couple of times, but it is probably important to keep that date in mind. So you'll need to move to -3 by then, or sooner if your current modules expire sooner, right? So again, it's it was already a 2+ year process, and it's an extensive process to go if you're going to do this on your own, because again, NIST is continuing to to raise the bar. And the bar will continue to go even higher, right? So again, with post-quantum cryptography, at some point, post-quantum cryptography will become sort of the only allowed, asymmetric cryptography. So right now you can still do RSA and elliptic curves, and right now you can start adding PQC into the modules. At some point, NIST will say you can no longer use RSA, you can no longer use elliptic curves. So we're not at that point yet, but that day will come, probably within 5 to 10 years. So something to prepare for. So the environment will continue to stay dynamic, whether it's entropy source validations and other things that are coming down the pipe. But right now, the main focus is that migration to FIPS 140-3. Yes, that's a great question. Where are you with your FIPS 140-3? Give you a second to answer that. So I think we'll largely already covered like the topics here, right? So again, you have, in addition to the -3 transition now, you have the PQC transition that's looming out there and getting closer and closer. And then you have, at least the entropy source validation, and there will, again, no doubt be others as well. And so let's talk a little bit right now about the implications for, if you're a government agency, right? So, so if you're a government agency, obviously you're using a lot of products, you're using a lot of services, and you kind of need to take a look to understand, what is the state of this and how much of it has already been moved to -3, and for things that haven't been moved, you got to be having conversations with your supply chain, with your vendors, to make sure they have a good plan for getting you upgraded, getting their products upgraded, and getting you upgraded by extension to FIPS 140-3, right? In the meantime, what's important to understand is that right now, if you have a product with an active FIPS 140-2 certificate, you should really accept that, right? There is no reason to kind of discriminate against FIPS 140-2. So again, as long as your vendor has a good path to get to FIPS 140-3 that you can understand and it makes sense, for the time being, if there's an active FIPS 140-2 certificate, it's a perfectly valid certificate. As long as it's active with NIST, this is something that you should definitely consider accepting. We heard of some sort of situations where there may be some hesitancy. We really don't think there should be, again, as long as the vendor does have a game plan for how they're going to ultimately get to FIPS 140-3. And really, for agencies, we recommend really prioritizing and really emphasizing that you would like to see cryptography that's FIPS 140 validated, that's an active status. Because again, if it's historical, it's not great because again, it used to be validated, but not anymore. So, not a great place to be, right? Because NIST is changing FIPS 140 standard for a reason, because the cryptanalytic techniques are getting better, so they want to stay ahead of the bad guys. So you want to do the same thing. And you also want to, take a look at what's actually on the certificate. So first of all, it's important to prioritize vendors that actually have their own certification, not the ones that claim compliance, but the ones that actually have their certification, because having their own certification puts them in better position to ensure that they stay, active and up to date. But also, it allows you to actually take a look at the operating environments that are in the certificate compared to the operating environments where you're actually running their products, and make sure that there's a match. And that's important because that's part of the FIPS 140 testing for a reason. So if somebody is presenting to you with a FIPS 140-3 certificate, but it only has 1 or 2 operating environments, that's probably not good enough, right? Unless those happen to be the exact environments that you're looking for. For instance, SafeLogic, we always prioritize having very extensive environment coverage. So as a matter of fact, our latest FIPS 140-3 certificate has 28 operating environments that are covered. We can add additional ones too, but it's really trying to cover the as extensive set as possible out of the gate. So for technology vendors, you need a plan for FIPS 140-3 migration for all cryptography in your products. You really have to consider your options. In most cases, we recommend against doing this as a DIY project. We encourage you to find a vendor that can help you accelerate and streamline the process to getting to -3. The good news, I know there are some SafeLogic customers here on this call. If you're a customer, we have you covered for the -3 migration. Come and talk to us. We can migrate you to -3 so you don't have to lose sleep over it. But if for folks that try to do this on their own, this can be quite a lift. So you want to have a plan in place and hopefully work with somebody that can help you through this journey. You'll also want to make sure that you align with your release schedule and provide enough time for testing. I mean, if you're a vendor or integrator, I mean, you have certain release trains and you have to align with it. And you're going to have to do some testing to go from -2 to -3, because if everything else is being equal, at the very least, there's going to be algorithm differences. For instance, triple DES used to be allowed at -2, not allowed with -3. So if you're using triple DES, you're going to have to go and use another, symmetric algorithm. So depending on what you're actually using, your journey could be more or less, just even if you have the validated module, to actually transition. So you want to start as early as possible. And again, make sure that your chosen solution will keep your FIPS 140-3 module validated over time through all the future transitions, whether it's PQC or entropy or anything else. So in other words, what you really want to do is that FIPS 140 easy button, right? You want somebody else like SafeLogic to do the heavy lifting for you, so you can go to do what you need to do for your business and not have to be a cryptography geek forever. So again, SafeLogic customers, we got you covered. I know there's a number on this call. Please talk to us, and we'll tell you about all the details there. So again, just to transition, and yeah, polling question: how do you plan to adopt FIPS 140-3 cryptography, validate cryptography? I'll give you a quick second to answer that. So SafeLogic, right? We've been around for a while. We've been around for over a decade. We actually started our life as a consulting company where we're taking people through this 2-year journey to get them certified. And then the big idea was look, we're doing a lot of the same things over and over. Why not just have a set of cryptographic libraries that we can validate with NIST, and then we can license them to our customers so that they don't have to go do the same thing? And this is what now has become the CryptoComply cryptographic software modules, a very extensive set of cryptographic modules. We combine it with FIPS 140 validation as a service, which we'll talk about in a second, but basically covering both your software support and certification for FIPS 140 needs, not just initially, but over time in a very white glove fashion. And we now have post-quantum cryptography solutions, which are also leveraging, the CryptoComply modules as well in our, PQC implementations. So our goal is really to sort of expedite and streamline the adoption of FIPS 140 validated classical and post-quantum cryptography. And, again, we view cryptography as very fundamental, so we think it's a very important mission. So how do we do this? Just to tell you a little bit about FIPS 140 validation as a service, it has fundamentally 3 pillars to it. There's a CryptoComply software, which I'll tell you more in a second. There is the rapid cert. It's getting that certification in your name, so you have that on the NIST website, which, as we said, it's very important. And then maintain cert, right? Maintaining both your software and certification over time, such that it kind of solves your problem once and for all in a very wide glove fashion. So CryptoComply is a family of FIPS 140-2 and -3 validated modules. So we try to be drop-in replacement for like popular open source, for instance, such that you don't have to rip out your whole infrastructure to use us. We're easy to easy to adapt, and we're actually easy to take out as well. So we don't impose any extra switching cost of you, right? So we kind of want to be a good partner. We want to be easy for you to deploy our cryptography. And we have a pretty extensive set of modules right now. We'll talk about them in a second. We have our PQC implementations now. As a matter of fact, we're running our early access program for PQC for customers who are interested to participate. It's a no-cost early access program for our existing customers. We're currently in the process now that we have the new standards from NIST for the PQC to kind of work with our labs and NIST to get those submitted. So our future -3 module will have full support for PQC. Like we said, we currently have a FIPS 140-3 module. We actually have, we're working on more than one, but we have one here that's validated for 28 plus operating environments. We try to do very careful work with our modules. For instance, we want to design them for maximum maintainability. So like we mentioned before, there's an idea of cryptographic boundary. We try to keep it very tight, such that minimizes the chance that you have to revalidate your module, or we have to validate the module on your behalf as things change. And you can definitely iterate through changes on your software, and that doesn't have an impact on the validation status because what's validated is all within the cryptographic boundary. So you're able to kind of go and evolve your software as you need to without having to worry about, is that impacting my FIPS 140 validation? But it's really a wide array of modules that we have. So you can see here, we have customers that use our modules from all the way, with the range being from like embedded systems all the way to the mainframes and everything in between. So mobile devices, servers on premises, services in the cloud. We pretty much operate everywhere, where people have cryptography. And again, just like plumbing, cryptography is everywhere. And we try to be, again, the drop-in replacement and compatible. And we try to cover as much of the environment as possible. So whether it's a variety of operating environments, operating systems, programming languages, and so forth, we want to solve 100% of your cryptographic needs, because people don't want to solve 80%. They're like, okay, you can solve my Java and C, but what about I got Rust, Python, and Go? How are you going to replace my cryptography there? We can be your partner to help you do that across the board and really cover your entire architecture. So that's CryptoComply. Again, the rapid cert is the process of actually getting you that certificate in your name. And we can do this within about 8 weeks. So consider that to 2+ years to do this on your own. We can get you your own module. So you take our module, you license it. As soon as you integrate it and you use it in FIPS mode in accordance with security policy, you're already what's called FIPS compliant, which was just described. But then we will get you to being FIPS validated / certified once we get you your own certificate in 8 weeks. So you can literally go from 0 to kind of that gold standard, not even to 60, I would say to 100. You can go in 8 weeks and you can get your certification with us because your certification inherits from ours. We're able to go through a separate queue and get you your own certificate so quickly. However, it doesn't stop there, right? There is maintenance, right? So the maintenance has two components. First of all, we provide software maintenance and support. So bug fixes, CVE fixes, minor upgrades, major upgrades, get included in this FIPS, 140 validation as a service subscription. We also do a lot of custom things, again, because our customers use SafeLogic module in a lot of different environments. A lot of the time we'd have to do custom builds with your custom compiler options, with your custom tool chains. We can do all of that. So there's a lot of software maintenance over time. And then there's also certification maintenance. So all the soft and hard transitions that NIST might have that are required to be done to keep the module active, we will do. Any revalidations, whether they're triggered by CVEs or something else, we will do. Transitions like FIPS 140-3 will do for you. Any future requirements like entropy source validations, anything else coming down the pike, that's all really part of that of the maintain cert. So a really important component, because if you were to do this on your own, you might get that certificate and you're like, okay, I'm good for 5 years. The reality is you're probably not, because every 6 to 12 months, again, there's going to be a transition. You're going to need somebody to keep doing that work actively for you to stay active, and this is what we do. So again, with post-quantum cryptography, this is a big deal right now. SafeLogic has been very intimately sort of plugged into this effort. We actually are one of the collaborators working with NIST Cybersecurity Center of Excellence, NCCOE, on the PQC migration project. I'm actually on calls with NIST and a lot of great collaborators. There's a lot of wonderful companies participating in that. I'm on those calls every Monday. I actually have the honor and the privilege to be running the PQC migration prioritization work stream. So once you discover all this classical cryptography that's going to be vulnerable to quantum computers, maybe hundreds or even thousands of instances, how do you prioritize what to migrate and how to mitigate if you're not migrating, all of that. So we're kind of trying to tackle that challenge, which is a pretty significant one. So we are very actively plugged in, that process. At SafeLogic, again, we've been running a PQC early access program for our existing customers. We are working on our, on our future FIPS 140-3 module that will also incorporate PQC algorithms. In the meantime, we have a number of products coming out early next year. For instance, we're working right now on, hybrid PQ-enabled TLS. We kind of see the TLS is, a significant use case for many people, especially if they can control both sides of the TLS tunnel. They want to, get to being PQ ready there. So we're doing hybrid, meaning that you can do pure PQC, but you can also do this with classical. If you're using classical, you can actually combine with our FIPS 140-3 validated classical algorithms. You can actually do 2 layers of encryption, right? You can do the classical and you can do another layer of PQC. You might ask, why would I want to do that? At least 2 reasons. The first reason is defense in depth. If either the PQC, because it's still kind of new, gets broken, or the classical, gets broken, quicker than we think, you have the double layer, so you kind of have the defense in depth. You can sort of fall back on having that other layer of encryption. The other thing is none of the PQC implementations are yet FIPS validated because it takes time. In many cases, the government agencies will have requirements to only adopt FIPS validated cryptography. So here you have basically adopt PQC and adopt FIPS 140 validated encryption. So obviously you can't yet get there with PQC. It's going to take some time, but if you're using hybrid, you can essentially check both of those boxes. You can check the FIPS 140-3 box with using FIPS 140-3 validated classical, and you can check the PQC box by using PQC. So you can kind of bring those two together. Intermediate solution. Ultimately, we see people will just adapt the pure PQC, but we're going to need to get more confidence in it and kind of get also get through all the FIPS validations for it as well. But we are really aiming to be ready to support our customers with PQC when they're ready to migrate. So again, the -3 transition upgrade, I think we're largely covered, but we have a current crypto comply, which we call version 3. We have both for server and for mobile that currently -3 validated, 28 operating environments. I think we might have the most extensive environment support right now of any -3 module that's available for licensing. We're currently looking to complete -3 validations for our crypto comply for Java, which should be coming out here in the next month or so. We expecting additional -3 validations, starting in 2025. The rapid cert process right now, we can do it now -2 modules. We can't quite do it on -3 quite yet, but we expect to be able to do it in the second half of this should have said second half of 2025. So sorry for the typo there, but it's definitely coming. NIST has taken a little while to ramp up with some of the rebranding scenarios because there's just a lot on their plate right now, and they're trying to kind of get their automation caught up, and some of that is still just kind of coming along, but it should be here soon. So again, if you are a customer of ours and you currently have -2 modules from us, please talk to us how we can get you upgraded in a smooth and orderly manner. And if you're not a SafeLogic customer but you're worried about how you're going to get to -3, please let's have a conversation and we'll see how we can help you. So again, we've been around for over a decade. We're blessed to have many great companies who have entrusted us with their cryptographic software needs. This is just a small subset of those. So we'd love to do the same for you as well. Again, we are about saving people time, effort, money, less expertise. Let us do the heavy lifting. Let us get you to certification in 2 months versus 2 years. Let us take care of your -3 upgrades. Let's take care of your PQC. And let's do all of that with a subscription. We offer this as a subscription, so it's a fixed yearly cost, and predictable costs over time, so you don't have to go work and pay labs and NIST, and you don't have to kind of take on this unknown. You know what it's going to be, you know that you're going to be covered, and you don't have to take the risk of being compliant, meaning you just use somebody else's module. But then if that somebody else decides to, whether decides or just does not manage to keep it updated and goes historical, creates problems for you, you don't have to worry about that with SafeLogic. So yeah, I think that's the gist of it. Again, we really much appreciate our partnership with Caresoft. We use that to bring again our crypto comply software, so both classical and PQC solutions to the public sector, education, healthcare. We are available in a number of contract vehicles and a growing list of contract vehicles via Caresoft, as you can see on the slide. And again, deeply grateful to the Caresoft team for giving us the opportunity to present to you all today. And with that, I think we have a few minutes for questions. So let's do it. I'm sure you have some questions.
Yeah, there's a few in here already, Evgeny. And again, if you guys would like to submit a question, please just look to that Q&A pod at the bottom of your screen. The first one I see is SHA-1 is still an approved algorithm for use in FIPS 140-2. And what about FIPS 140-3?
Yeah, great question. Yes, so in general, no, not approved in FIPS 140-3. There may be some exceptions depending on sort of what you do. Like for instance, if you have some historical signatures that you still need to verify, you may be able to do it for that, but not for generating new signatures. So hope that helps. But that's kind of the general gist of it. SHA-1 is a great example of a transition that actually NIST had a while back, and it was actually shown to be broken pretty long time ago, and then it was shown to be even more and more broken. But if we do discovery right now and take a look at what's out there, there's still a lot of SHA-1 out there. So that just kind of gives you a sense of how difficult it is to go through some of these cryptographic transitions, the effort that it takes to do that. So kind of gives you a little bit of preview of what we're going to be up for when we do the PQC migration, because the PQC migration is going to be substantially larger than just moving from shell one. But this was kind of a microcosm, if you will. But yeah, but hope I answered your question there. Let's go to the next one, Holly.
Okay, yeah. If a module needs to be updated for any reason, does it still have to go through the same 2+ year review, or is there a shortcut?
Yeah, great question. So there are different validation scenarios. It depends on what is the update. So typically, for instance, CVE fixes can go through a quicker review. And it's not to say that it's quick, right? I mean, it's still not like tomorrow, but it's not 2+ years, right? So for us, for instance, we're either doing major validations like from scratch or constantly doing revalidations because of some changes. So it's kind of just a fact of life. But no, there are different scenarios that are available to do validations depending on what the change is.
Perfect, thank you. Then for the next one, is there a simple listing of exactly what the FIPS requirements are, encryption, etc.?
There is a listing. I don't know if it's simple. I would not characterize it as simple. It's very dense, I would say, code for implementing cryptographic modules. We actually have some on the SafeLogic website that we will maybe share with folks after the webinar. We'll be happy to share some links. But in general, it is pretty extensive, a code of requirements and also implementation guidance. So it's there, but I would say that unless you live in this world of FIPS, it's not necessarily that easy to digest for the people who are not sort of deeply ingrained.
Perfect. Okay, the next one, when you say we can't do new acquisitions with a historic system, does that mean we can no longer issue an order for it or that we can no longer accept delivery?
It's a great question. Look, this is really, as far as I know, it's agency by agency sort of decision. So we don't, we are not going to be in position to tell the agencies what they can and cannot do, right? I mean, they will know, right? So I kind of don't really want to venture into that territory. In general, my understanding is for new procurements, right? So like a new procurement, like issuing an order, you kind of want to make sure that the cryptography that your vendor uses is active, has their own certification, and ideally at this point, if it's -2, it's okay. But what is their plan to get to -3? Those would be sort of my recommendations. But sort of actual sort of requirements, legal requirements that agencies have, that's something that I wouldn't want to sort of provide guidance on.
Perfect. And looks like just a couple more in here. What is your position on running OS in FIPS mode? Some modules like Boring Crypto require only approved mode, while others like OpenSSL on RHEL require the OS in FIPS mode.
Yeah. So, we have customers that do, all of these things. In general, we find that there are benefits to, rather than doing the whole OS and FIPS mode. Sometimes that may be necessary, but in general, we see benefits to take a sort of a finer grained approach, actually figure out what specific applications you have that are in scope and actually getting those applications that they use of cryptography to use a FIPS 40 validated module. Boring crypto and Go, that's a whole, that's a whole animal altogether. We actually do have a relatively new crypto comply for Go module. The traditionally challenge with that is that boring crypto, obviously it's maintained by Google, but they don't necessarily make any promises about API stability. As a matter of fact, they're very explicit about it. So as you begin to change things, it's quite easily to get yourself out of validation and having to sort of redo it. And so it can be risky for many organizations. So we have our own crypto comply for Go module to kind of solve that problem. But we see Go being a particularly traditionally thorny topic for customers. But yeah, our general advice is usually try to take a finer grain approach and figure out what applications need to be FIPS validated. The use of cryptography and target that. versus just taking what might seem like an easier approach. Let's just get the whole OS, but that comes with its own challenges. But we can support you in both of those journeys.
Awesome, thank you. And then this one's a little bit more broad, but what is the post-quantum encryption? I'm having a bit of a hard time with what that exactly is.
Yeah, so absolutely. So over the last several decades, we have public key cryptography. Public key is meaning asymmetric cryptography. It means that I have a public key and a private key, and essentially a lot of the time it's used for sharing a secret. So if you want to have a TLS connection, right, you're ultimately going to use some sort of symmetric key because it's more efficient. But you're going to need to use public key cryptography and certificates to be able to create a handshake and distribute that, right? So usually the algorithms that are used there are RSA and elliptic curves. They're both based on a mathematical, what's believed to be a hard mathematical problem, is basically factoring a large number that's a product of very, very large prime numbers, right? So that has been difficult for classical computers. Unfortunately, looks like quantum computers, because of something called Shor's algorithm that got published in 1994, they're going to be able to crack it literally within minutes. So now we need different types of mathematics for this public key cryptography asymmetric. So if you look at what NIST just standardized, most of those are based on something called lattices. So it's just a different type of mathematics that we believe to be hard also in quantum computers. I say we believe because none of those things have actually rigorous proofs of hardness from a computer science perspective. It's just have enough time. Smart people looked at it, tried to break it if they can't, right? That's kind of like that sort of approach. And obviously we don't yet have a fully functional quantum computer yet that we can try it out on. But essentially it's a different class of cryptographic algorithms that will replace RSA and elliptic curves for the purposes of public key cryptography, and what makes them post-quantum cryptography, because they are resistant to quantum attacks in quantum computers. Sometimes people call them quantum resistant algorithms or quantum safe algorithms, some other terms that people use sometimes.
Awesome. Thanks, Evgeny. And I know we're coming up on time here. We're actually a little bit over, so we'll fit in one more question. And then if anyone else had questions, we'll definitely follow up with you after offline. But for our last question, is FIPS 140-3 a hard requirement for any company deploying SW/HW encryption modules?
Is it a hard requirement? Well, I mean, it is a if I understand the meaning of hard, right? I mean, it's something that will be like, in other words, if you need to have, if you currently have FIPS 140 validation requirements, you will need to transition to -3 because -2 is just going away. So from that point of view, if FIPS 140-2 is a hard requirement for you, FIPS 140-3 will be a hard requirement for you. And the hard date for you is going to be September 2026, if not earlier. Again, if the modules you use today, they sunset earlier, it's going to be earlier than that, but the latest will be September 2026. So if I understood that question correctly, that's my answer. If by hard, if what we meant is it hard to actually get there, the answer is it depends. If you try to do it on your own, it's going to take a long time. If you use a company like SafeLogic to manage that for you, it really shouldn't be that difficult.